Thank you, and thank you everyone for coming. So I'm Olivier Benjamin, and my colleague is Benjamin Robin. So if you know Robin Olivier, we're interested. Um, and we're going to be talking to you about sbom-cve-check, and that's a tool that we've written to do analysis of SPDX3 SBOM, so software bill of materials in Python. A few words about us to start. So we're embedded Linux engineers and security engineer at Bootlin. Bootlin is a development and consulting company, very focused on open source, and we also do training. All of this around embedded Linux. So we work on a variety of projects that can be bootloaders, for instance, U-boot. We also do kernel development. We have a few maintainers on our team. And of course, we do build system integration. And our CEO is very well known for being part of the Buildwood project. And we have a lot of work with Yocto, and some of our colleagues are we have the documentation maintainer for Yocto, for instance, and we do a lot of work for Yocto in context of the squad team. We're both based out of Lyon. Boutin has a different office in the southwest of France, in Toulouse, but we're in the other one. So sbom-cve-check. First, what is it? So as I mentioned, it's a Python tool, and we've tried to make it standalone, meaning it doesn't run as part of a different tool. And we have tried to have as few dependencies as we could get away with. Its input is first and foremost an SBOM, so a software bill of materials. That's an inventory of the software that is included in your build, including its version. Several formats exist for this type of information. One of the most well-known ones is Cyclone DX, and the one that is supported and backed by the Linux Foundation is the SPDX format, and we currently support two versions of the SPDX format, 2.2 and 3.0, 2.2 being the one used by Yocto. Optionally, we also take a VEX manifest that can be generated by Yocto. There's support for it in the VEX class. This has made it into upstream OE core in 5.2.4, but it's also in StyHead. And optionally as well, but very necessary for the purpose, is enrichment databases. So those are databases in different potential formats that are going to hold information about the CVEs that you want to analyze and list. So the main goal of the tool is to look up which CVEs impact the software that is contained in the software bill of materials, and therefore could affect the systems on which that software is deployed. Just because the CVEs impact the SBOM does not mean necessarily that they will impact the system, because there will be some runtime configuration. The service might not be exposed, it might not be launched. So there can be a lot of things here, but it will give you sort of the max threat that your system could be under. And then further assessment can be done by a human. It gives you this assessment in a format that is compatible with other tools, and so you can feed it to other tools, hopefully. The aim here is that the sbom-cve-check would be one step of your process when analyzing your build or your system for CVEs. It's not necessarily going to be the only tool that you use. All in all, the functioning is rather close to the CVE-check class in Yocto, with a few differences. So why do we need this tool? So basically, CVEs are a big keyword of the times, and they're going to get more and more this way, partially because of the CRA. So the CRA is the Cybersecurity Resilience Act. That's a law that has been passed by the EU that essentially mandates people to look at their CVs. I heard a notification. Was there a question? Good. Never mind. So essentially, not having a good inventory of your CVs is going to get rather expensive, and this is going to be a something that is mandatory to do for compliance. As I mentioned, Yocto has a CVE-check, which does some of this. The problem with it is that it's run at build time, meaning that it is part of the Yocto build. That's a problem because CVE checking and analysis is already a task that can be not the most fun, and it is already intensive in terms of effort. So if we add that you also need to build, that just makes the whole thing longer. And it requires this added step of building the software. And so you're going to want to be looking at CVEs weeks after you've built the software, sometimes months, and potentially years, because that's sort of the idea of how long the support window is going to be for a lot of the software. And you might not want to rebuild it from scratch every time you want to do this, even years down the line. Also, something that is worth thinking about is that now everybody who provides software is going to have to provide SBOMs with it, and they're not necessarily going to also provide the build instructions and an easy way to build it. And they might not use a build system, they might not use Yocto, but they should be able to provide an SBOM in a compatible format, and then you can still use sbom-cve-check. The aim was also that it would be easy to use. As I mentioned, we really wanted it to have as few dependencies as possible and to be easy to install and use. And the caveat of that is that it's not filled with bells and whistles. It's not going to have a GUI. It won't output like very fancy graphs or statistics for you. So it's really one step of the process. So here are dependencies. The top one is the SPDX Python model. Well, we need this because we're working with SPDX, so there's really no getting away without this. And then we have a few optional dependencies to make your life just easier, like rcomplete or YAML support. And then we have the dependencies that come from documentation and from testing and linting. So really the 2 or the 4 lines at the top are hard dependencies, and the rest is a bit optional. And so we think we get away with really few dependencies. So the tool takes some input and gives you some output. Here's what's supported. So it supports several CVE databases. So the NVD and National Vulnerability Database, for instance, has a dump in a GitHub repository of its feeds. And the same goes for CVE list. And then annotations are a big part of the process because they give you additional information about the CVEs that you're currently running through. And this is what is going to enable you to make a decision as to whether you need to have a closer look, whether you need to patch it maybe, and with what urgency. And there's a bunch of different formats for this. And of course, some of it might want to be, oh, we can just ignore this. And the multiple formats are, so OpenVex is a standard format for this. It's the Open Vulnerability Exchange. It's powerful, a bit complex. Yocto uses a custom format that is the output of the Vex class that I mentioned before. We also have very simple annotations that are just YAML files that you can then use for if you don't need something a bit more flexible, but you need something lightweight that you can easily parse. And we also support providing annotations in an SBOM, in SPDX3 SBOM, if you need them, for instance, to be compatible with other tools potentially, that's going to be a format that is a bit less legible and a bit harder to parse. As export, you can export an SPDX3 SBOM, but only if you give it an SPDX3 SBOM as input, because crafting SPDX3 fully is a challenging task. It's not a simple format at all. Otherwise, you can also use CSV, and we are compatible with the Yocto output from cve-check. And now my colleague Benjamin is going to tell you more about how the tool was designed and how it works under the hood.
Yeah, thank you. As you can see in this schema, sbom-cve-check has the following design. The tool takes as an input an SBOM file represented in yellow in the schema. It also takes various CV databases and annotation databases represented in pink. Some SBOM formats can contain annotation. For example, this is the case with the SPDX3 format, as you can see in this schema. The databases are indexed. The index is a map in memory between the product name and the list of potentially associated CV identifier. The vendor name is not part of this index, only the product name is used as a key. The index is stored to disk in a cache file to speed up the next execution. For each SBOM component, the tools find all associated CV and then compute associated CV assessment. And finally, the tool can generate one or multiple export files, represented in light blue. Global filtering can be applied, for example, to only export vulnerable CV. Each of these inputs and outputs elements are implemented by built-in plugins. There are three kinds of plugins. Each needs to implement the associated interfaces. So there are three kinds of interfaces. One for SBOM file type, one for database type, which include CV database, for example, for NVD, or annotation database, and one final type for export formats. These designs allows to extend this tool with custom functionalities. Indeed, in addition to the built-in plugins, sbom-cve-check can load custom and external plugins that the user can provide. This allows to add new type of format that is not currently supported natively by these tools. For example, if the user wants to use a custom SBOM format that is currently not supported, like a web API or something like that, a new custom CV annotation format, or for export, a custom report format, a web page, a PDF, or something like that. When generating a report, one thing you might want to do is to also ignore automatically some CV. The tool can automatically mark a CV as ignored if the affected sources, which contain the vulnerabilities, are not compiled in the deployed binary. For that, the SBOM needs to contain the list of compiled source for each component that needs this extra processing. Hopefully, this is possible in Yocto. To do that, you need to define the SPDX include compiled source to 1 in each recipe that need to provide the compiled source in the SBOM files. For this to work, we also need a CV database that provides the list of affected files. Fortunately, most of the Linux kernel CVs have this kind of information. But this extra processing is not limited to the Linux kernel components. This processing can be realized for any components since this is implemented in a very generic way. You just need a CV database that provides this list of affected source for this particular component. To execute the tools, here an example of command lines. There is three concepts. These three concepts that we already mentioned are also found in the command line interfaces. In blue, the input SBOM. In this example, this is the path to the SPDX3 files. In orange, an annotation files. In this example, a Yocto Vex manifest, which is seen by the tools as an annotation database. This is quite simple since this is only a single JSON file. In purple, the export configuration flags and the export formats and output file path. But more complex annotation database can be loaded. For example, the annotation database can be declared using a TOML configuration file. In this example, we have declared a simple annotation database, which is a directory containing one or more YAML files per CV annotation. This directory can be a Git repository that can be cloned if needed and updated automatically. This period between two updates can be controlled thanks to the auto-update max age option. And this particular simple annotation database type also take a glob option, which is a list of directory or pattern where to look for YAML files. To execute the analysis, the following steps are executed. It first downloads or updates the databases, which can take a bit of time. To speed up this downloading step, a shallow clone is done by default. Then the various databases are indexed. The index is stored on disk into a cache file to speed up the next execution of the tools. This step takes about 1 minute if the cache is invalid. And finally, the analysis is executed, which takes anywhere from a few tens of seconds up to 2 minutes, depending on the complexity of the SBOM and of the output format. Indeed, generation of a big SPDX3 output file can take a bit of time. If you want to take a look at this tool, the source is available on GitHub under GPLv2 license. Contributions are of course welcome. And the documentation can be consulted from the Read the Doc website. This is the first version of this tool, and there are many various improvements that are planned in the short or medium term. For example, we plan to add support for Ubuntu CV tracker repository. The goal is to automatically detect if a Linux kernel patch was backported. We also plan to add more export formats, like for example OpenVex, and also CycloneDX SBOM support as input. In a more distant future, we want to be able to generate a SBOM, CycloneDX, or SPDX3 as output, even if the SBOM specified as input is in another format. But this stack is a bit more complex, so this will be done a bit later. If you want to try it, first you have to install the tools using pip. If you want to install the tool with all optional dependency, you can execute the command shown on the slide. This is recommended to install the tool inside a Python virtual environment in order to avoid polluting your Python global install. Then you need the SBOM and optionally the Vex manifest generated by the Vex BB classes. This is optional but highly recommended. For more details about that, we recommend to read the documentation about it. Since Yocto 5.2, the SBOM is generated in SPDX3 format, so there is nothing to specify in Yocto configuration for that. These artifacts, the SBOM and the Vex manifest, can be obtained from the Yocto deploy directory. And finally, you can execute the following command as an example. This is a very simple one without filtering, without any complex annotation database. This is just an example.
Okay. So that was it for sbom-cve-check. Thank you for your attention. Thank you for listening to us. We hope this gave you an idea of how to try it, and we hope that it can help in your workflow when you're looking at CVEs and trying to understand what's in your build. We wrote it because it filled a need for us, especially to run it outside of the build, and we hope it does the same for you. If you have any questions, I think we have a bit of time for it. And if there's not enough time right now, our email's on the screen, and feel free to reach out.
I've seen a couple of questions, but in the chat.
Can you read them out?
I need to check. Marta, I don't think I understand. Maybe she can explain what she meant by precision CV-check does not require a build. SPDX generation does, or however.
Yes, but what we mean is that it has to run during the build.
Yeah.
CV-check is integrated to the Yocto build, so you cannot run it on
outside of
artifacts that you exactly.
there is one was Anis ask, does the output support to be processed by the tool like dependency track or defect dojo? Dependency track, I think, support importing an SPDX2 format. So I don't think this apply because we can't really add annotation in this format. I don't think dependency track supports SPDX3 format. It supports ClientDX, I think. I don't remember.
I think so. This would be
Yes, yes, attacked supports sbom-cve-check, but not SPDX.
Yeah. So right now, we plan to add outputs in ClientDX. So this will be possible one day.
Yeah, essentially that would be an output format plugin. It's just that we sort of prioritize the ones that we would need, and we wanted output that was compatible with the output from Yocto and SPDX3, and so Cyclone was a bit lower on the priority list.
Yeah, there was an answer that explains that. Yeah, you can. The solution will be to convert the SPDX3 file to a ClientDX. Yeah.
Yeah, essentially.
Have you seen the project besides the kernel that contain the file affected by the kernel? I think so, but it's quite rare. How easy to add additional activities? How easy to add additional CV databases? You need to implement the virtual interfaces of the database interfaces. So it's not that hard, but there are kind of some requirements. You need to be able to index it, and then you need to be able to query a specific CV. All the information about this CV. Basically, this is very basic summary about it. And if you implement that, everything is going to work, hopefully.
And then you have a few examples that already exist in the
Yeah.
tool, because this is how we implemented the current CV databases that are supported. So
Yeah.
it's not like
CVD
there's a
and
core of them, yeah, exactly, in the NVD. It's not like there's core CV databases and then there's the ones that are brought in by plugins. They're all on the same footing.
yeah, and maybe I was not very clear, but CV databases and annotation databases are seen as have a common interfaces. Yeah, so you can see the annotation databases like a CV databases kind of. They shared common interfaces. So there is a lot of example. I mean, I'm sure I'm missing question.
If we missed your question, you can also unmute and just ask it directly.
Can this tool load the CV report that were previously generated by sbom-cve-check? Sorry, I don't know this one. So no, I think. But you can write the plugin to do that.
Or, open a GitHub issue, and if it
Sure.
gets hyper popular and everybody wants this as well, we might just pick it up and decide to do it.
Is it possible to use this tooling in older Yocto release? The old Yocto release, the short answer, no. But you need to take a look at the documentation. There is a table of compatibility with all the version we support. But basically, the two last LTS.
Yeah, essentially it's going to be starting from ScarthCap that it's
Yes.
it's
And
used.
yeah,
Unless, somebody wants to go through the effort of backporting all of the sbom generation and all of the vex annotation generation to older Yocto releases.
I don't think it's possible because the support is ended. And I'm sure it's going to be merged, but yeah. Will it be possible to run the command from Bitbake environment? I'm not sure I understand that part. Will it be possible to run the command? This
Yeah.
is a standalone. This is a fully standalone tools. So
Yeah, we could add
no.
it to a layer essentially. I
Yeah,
mean, we could just
sure.
make a layer for it and then run it from Bitbake. It's there's nothing that goes against Yocto or anything. Like it's not that running inside of Yocto is bad or anything. It's just that we wanted to also be able to do it outside of it. But if you just package it and put it in your native sysroot, there's nothing that's going to prevent you from running it. And then if eventually this works out and we decide that well, maybe it's easier to use sbom-cve-check than the cve-check class, then great, we'll just put that in the layer and then you can just use that directly.
There's another question about modules. Does it make a distinction between runtime and build package? And are there any plan to support for whether certain kernel driver modules are configured? I think you meant if the module is not compiled and if there is a vulnerability in it, is the CV is going to be marked as inured? Yes. If everything is done properly, but I'm not sure. about the question. Yeah. There's a question about are you looking to provide Yocto layer or recipe for that tool? At short term, no.
I mean, if there's a strong need
Yeah.
for it, again,
Yeah, sure.
if an issue pops up on the GitHub and everybody is like, oh, we absolutely need a layer to use it, we might just create one and then can use it directly from Yocto. We really wanted a minimal viable product of you can run this outside of Yocto, very minimal dependencies. Given that the dependencies are so few, I think it's not going to be a massive amount of work to create a layer for it.
I think there's a good question. The VEX files input are optional. What info do they provide? What the SPDX SBOM input does not. The SPDX files can provide all of the information in the VEX files. But yeah, I didn't want to explain fully, but this is explained in the documentation. But if there is a variable in Yocto to provide all of the intention inside the SPDX3 files. But in some cases, if you have a lot of modules, kernel modules, you will have very big SPDX3 files, more than 2 GB, and the generation is quite slow in Yocto. So to work around this issue, basically we use the default. So do not provide all of the annotation inside the SPDX3 files, and put them in this VEX manifest. That's just a workaround for performance. That's it. The information are the same, basically. I hope the answer was quite clear. Did I miss some question? Please repost if I miss something.
I think we're anyway running out of time. I don't know how much longer we
This
can
is
go.
technically the break. You're welcome to go a little bit longer if people have questions. Otherwise,
Okay, cool.
How does these tools handle non-CV vulnerability like GitHub Advisory, UVD, etc.? Currently, this is not really supported.
Then again,
but
we call them
need to extend that.
Yeah, but we call them CVEs because that's the main way to refer to them. But you could sort of have a different process for the same
Sure.
for different type of vulnerabilities. If you can represent the information in the right format, like the SBOMs are not specific to CVEs at all. They're talking about vulnerabilities, so they're not tied to a specific type.
But right now in the implementation, we are just looking for CV. But we can extend that pretty easily. But yeah, currently this is not implemented.
I just want to say that it looks very nice, and it's nice that you also use what I upstream in the Spring with the filtering for the kernel CVs. And I'll actually give it a try, because I had some internal scripts that doing similar things. That's why I was asking if to plug in external other databases, because we have some proprietary information that it will be nice to connect to this.
Sure. I mean, essentially, can write a plugin for it, and it should be it should then be handled, right? We have this simple format. If you want to, have a very simple, easy way to put that information. If you have your own format, then you get to write the.
I know it just I also have Python scripts with JSON data that just putting in the
Oh,
code.
okay.
I don't think it should be that complicated, and
Yeah, it
also
shouldn't
calling
be.
some APIs. So it's basically you need the CVs for a specific product, and then list of the CVs, and then the range if it's affected or not affected.
Yeah, you're looking the code.
No, I haven't looked at the code yet, so it just I will probably look soon.
That's pretty much it. Yeah.
I think a lot of people try to solve these issues.
Yeah.
Yeah.
But nice presentation.
Thank you.
Thank you. Yeah. I think we can wrap up.
Yeah, I think we can let people go on their break. Once again, thank you for your attention and for your questions. And don't hesitate to drop us an email or a GitHub issue to tell us, what you would like to see, what you think of the tool.
Okay, thank you for a great presentation and for all the questions. Wonderful. Okay, we'll take the next one starts in at the half hour, and everyone take a break and come right back.
Thank you.
Thank you so much.
Bye.